Hi, my name is Jamal Ashraf. I'm working on Java concept early object or big Java uh, chapter 5 decision. This is part 6. I have covered the last 5 parts already. And we are looking at part 6 that we're going to be using problem solving, selecting test cases. I would suggest you get a pen and paper ready or some document in your computer. I personally prefer writing on a paper. I remember it because I can see it, but everybody has a different way. So when we get to do this, you can make some notes and then you can answer the questions at the end. So we have different ways of creating test cases. So when we are developing actual real life application, we have different tests that we have to consider from the developer to the group to the application level and so on and so forth. So one of the tests, before I forget, and this is going to be as part of our software engineering process that we have to create our test cases before it's part of the design. So we generally create these things talking to the customer back and forth to get them done before we start writing code. It's going to help us how to test, unit test what we're doing, and of course at the end to test. So one of the test cases is called black box testing. So the person who's testing it, he doesn't care what the code is. It's just testing it to see how is it working. So you can think about it, those people that they think they got a very good job offer in a gaming company, that they are called test engineer, and all they have to do is just run the program and look for the bugs. So playing the game is different than when you are looking for bugs. You have to be very particular, you have to document things, you have to see or look for the problems. That's called black box testing. So looking for bugs without knowing what the code is about. Next one is called the white box testing. This is about how the structure of the program is. We generally do a unit test for each method. So we just go that detail and it's in the level of the programmer. Generally in real life, we work in teams, and before we submit our team work to the group as a whole, we need to test our stuff. So when I'm sending it, I'm saying all the method that I wrote has been tested, has been checked. Next one is called code coverage. Is the how do we how many parts of a program have been tested? So we have a huge program, the one that we did for airport security way before 9/11, early computer coming up on board. We had like 97 people working on the project, lots of documentation. So the project manager or project managers had to know where we are, what is being tested, what is not being tested, and so on and so forth. In some detail of it, we go to every branch. We're going to look at see how is done. We're going to do the case scenario, the test cases for testing them. Then we have boundary test cases, and this is something that we're going to be practicing moving forward. So if I have certain things that I am getting into my program, I want to check the boundaries. Generally for me is if I have a boundary or boundaries, I'm going to go look at the middle part, then I go to the boundaries, then I go outside the boundaries. So let's say that I am looking for a certain age scenario from 25 to 30 or 21 to 25 or 18 to 21. So when I have that range, then, and I'm working on the program to create it, I'm going to create a test scenario. Again, we're going to do this together. So if I have a boundary of 18 to 21, I'm going to put something in the middle, 19 or 20. Then I'm going to put something outside, 15, 35. And then I'm going to check the boundaries. What do we expect if it's 18? What is expected if it's 21? So we have to test all of those things. It's not like, oh, I got to get this on and move on. So we're going to be doing this before implementing the program, and that's what we're doing in our design project, and we're going to be talking more about this. So let's look at application that we are doing the tax return, very, very simple tax return. And we're going to talk about the detail of it. We have seen this before. So depending on if the person is married or single, and depending on the salary, they're going to define how much of tax they're going to pay on that. So if it's 32,000 or less, they're going to pay 10%. This is not the actual tax return. We're just playing with these concepts. And if it's over 32,000, it's going to be the 10% for 23,000, which is 3,200. That's the 10% of the first 32,000 plus 25% of the remainder. So the first 32,000, so let's say it's 35,000, the first 32,000 is going to be 10% plus 15% of the remainder. So the 3,000, if I have 35,000 minus 32,000, I'm going to have 3,000, which is going to apply to 25%. Same concept for married people, but the range goes from 32,000 to 64,000. So that's what we have as a requirement. Remember, in real life, we are always working for other people. We have a stakeholder that we are working for. Most of us are not going to end up working for ourselves. So we have to pay attention to the requirement document. We can give suggestions to the requester, whoever is requesting. But if that's the document that we have to write a program based on the requirement that we have. We cannot just add things or deduct things because we don't like it. All right. So at the beginning, we have two possibilities. It's going to be either married or single. So we can ask the user for M or S, married, single, or we can ask, are you married? And it can say yes or no, and so forth. Then we're going to be looking at the boundary conditions. So where are my boundaries? And we're going to check the boundaries to be sure that what we're looking for is inside the boundaries. And we talked about the boundaries early on. So if the boundary is 32,000, so we're going to check something for less than 32,000. We're going to check for greater than 32,000, and we're going to check for 32,000. And then we're going to think about what can go wrong. So when we are checking for the input, we have to think about what can go wrong. Remember, we have limited space. So depending to the variable that we have so much room and we can read so much stuff. So if I have the salary and somebody put $5 billion, is that acceptable number for my program or not? If somebody put a negative number, is that acceptable or not? So when we're looking at the input, we got to ask the question if this is interaction, if this program is interacting with the user. That means I have the user in front of the computer, then maybe I can ask the user to correct it. So, or ask the user to see. I remember I was working in an office, and one of the people working in the office had a grandma who was 100 years old, But at that time, the age in the hospital system was 99. So every time the max was 99. So every time she would take her grandmother to a hospital, it would be rejected because the age was not in the range. So most of the programs are running in the middle of the night while people are not on the computer. It's called batch processing. Uh, so most of the time we don't have the user in front of us, or we can have potentially lots of data. So let's say I'm reading a data of 100,000 record data. There is no one person sitting over there and entering those things. I'm going to be reading it from the web page, from the database, from a file somewhere. So there is nobody there. So if there is nobody there, the question is, can I fix this and move on? So the concern is, I don't want to shut down the program. Can I move on? So for example, in this case, when we are asking the person married or not, if they put a wrong data, can we put a single as a default value? So we're going to ask if you are married, and if the person says yes, we take it. If the person put N for no, we take it. But if somebody put A, for example, which is out of range, we're going to change it to, of course, we're going to check it to see if the user is available. If not, we're going to change that A to N. So you give me a wrong data, I'm going to assume that you're single. Same thing goes with the dollar amount. So we are working in a neighborhood, we are working in an office, we're doing this program for certain types of people, and we have the average salary that is, let's say, $70,000. So my neighborhood that I'm using this one, or the people who will be using this application, the average salary is about 70,000. So they put 140,000, 200,000, it's okay. But if they put 500,000 or $1 million for their salary, it seems like it is not correct. So we got to do something about it. So we are looking at this, and we're going to think about what kind of a test we can do on these things. We are looking at, okay, so if I am working with a single, so my range is 32,000. So I want to check something below it. I want to check something above it, and I want to check exactly that. So I am going to do 30,000, 72,000. I'm sorry, 30,000, 72,000, and 32,000. So those are going to be my case is for a single with 32,000. So we want to check below it, above it, and on it. So in this case, it says at most 32,000, and it says over 32,000. So that means if it's 32,000, it should still be 10%, nothing more than that, which should come up with 3,200. So we want to test these things to be correct. Same thing goes with a married person with 64,000. I want to check something below it. I want to check something above it, and I want to check that 64,000. We have to do these things outside of our program. We have to get some numbers, and then if we have the customer, we want to check it with the customer to be sure we are doing it correctly, and then we can test our program based on those. So we're going to give these things to our test engineer, and the test engineer is going to be running these numbers over and over to see if something goes wrong. All right, so we get to the self-check. That's the end of this part. And I hope that you have a pen and paper that you can write these things down so we can work on it later on in the class. So the first one is using a figure 1 at the beginning of the chapter as a guide. Follow the process described in this section to design a set of test cases for the elevator simulation Java program in section 5.1. So you can put a pause on this video right now, create a table. If you're using your computer, you can create an Excel sheet to have columns on it and create a header for your columns to set your tests. Next one is what is the boundary test case for the algorithm in How-To 5.1 on page 190. Actually, the page is different from different books, so let's not worry about the page number. Just look for the How-To 5.1 and what is expected output. Next one is talking about using the figure 4. Again, the page number, don't worry about it because we have a different types of books. Each one of them have a different page. So the online one, the Java concept, big Java. So just look for the figure 4 and follow the process described in section 5.6 to design a set of test cases for earthquake.java program in section 5.3. Again, I'm going to create some table and so on. Put a pause on it, take a few minutes to do that. Next one is talking about some kind of a medical robot that has a sensor returning an X and Y location. These are done in centimeter. Remember, because of the mistakes that has happened before, when you go to the scientific calculation, medical calculation, they generally go with the metrics, so there wouldn't be any mistakes. So we have a centimeter here, 2 centimeter, and it says that outside of the circle on the boundary, and we want to check to see the difference of 1 millimeter. Okay, so I'm going to stop this one right here.